everyone, I am Nicole Alemani Mallorca, a grade 11 STEM relational student. For this video, I will be sharing to you my performance task in statistics and probability, wherein I will be performing or explaining the steps on how to solve the mean and the variance of the sampling distribution of the sample means. So without further ado, let's get started. First, we are tasked to form a group of 4 members from our family or relatives or friends and make sure that the weight of each member is different from each other. Next, we will get the weight of each member and consider this data as elements of the population. So here are the list of the weight of each member of the group. So here are the list of the weight of each member of the group. My mother's weight is 57 kilograms. My tita's weight is 55 kilograms. My brother's weight is 49 kilograms. And my cousin's weight is 47 kilograms. So the population consists of 47, 49, 55, and 57. Next, we are tasked to list all the possible samples and the corresponding means. Suppose samples of size 2 are drawn from the population. Construct the sampling distribution of the sample means and solve for the mean and variance of the sampling distribution of the sample means. To do this, I will be referring to the steps given in the module. So here it is. Step 1. Compute the population mean. Step 2. Compute the population variance. Step 3. Determine the number of possible samples of size n equals 2. Step 4. List all possible samples and their corresponding means. Step 5. Construct the sampling distribution of the sample means. Step 6. Compute the mean of the sampling distribution of the sample means. Step 7. Compute the variance of the sampling distribution of the sample means. And Step 8. Construct the histogram. Now let's proceed to Step 1. Compute the mean of the population. To do this, we are just going to refer to this formula. Mean equals summation of x divided by n, where x is the data and n is the number of elements. So our x will be 47, 49, 55, and 57, or the elements that we had earlier, and our n will be 4, since we have 4 datas. 1, 2, 3, 4. And n stands for number of elements. What we are going to do is we are going to add this and then divide it by 4. So, 47 plus 49 plus 55 plus 57 equals 208 divided by 4 equals 52. So, the mean of the population is 52. Step 2. Compute the variance of the population. What we are going to do here is we will construct a table with 3 columns, where the first column will contain the elements of the population represented by x. The second column will contain the difference between the elements of population and the mean of population, which is 52 that we have earlier in our previous step. And the third column will contain the squared of the answers in the second column. So our first column will contain 47, 49, 55, and 57. We should also bear in mind to arrange these elements from least to greatest. As I said, the second one will contain the difference between the elements of population and the mean of population, which is 52. So 47 minus 52 equals negative 5. 49 minus 52 equals negative 3. 55 minus 52 equals 3, and 57 minus 52 equals 5. Now, in the third column, we will square our answer here. So, negative 5 times negative 5 equals 25. Negative 3 times negative 3 equals 9. 3 times 3 equals 9, and 5 times 5 equals 25. Summation of x minus population mean squared equals 68. Or this is the total when we are going to add all the values here in the third column. 25 plus 9 plus 9 plus 25 equals 68. Because we have the value of this, we can now solve for the variance of the population. The formula for the variance of population is sigma squared equals summation of x minus population mean squared divided by n. We will just simply substitute this to have the answer. So we have 68 from our summation earlier and 4 from the number of elements. Dividing this, we have 17. So the variance of the population is 17. Step 3. Determine the number of possible samples of size n equals 2. We are just going to use this formula. So here, n are the number of elements equals 4, and n are the number of possible samples of size equals 2. To solve this, we will just do substitution. You can also use calculator to solve this easier and faster. So as you can see, we have here the answer of 6. So this means that there are 6 possible samples of size 2 that can be drawn. Now let's proceed to step 4. List all possible samples and their corresponding mean. We will create a table with 2 columns. The first column contains the possible samples and the second column contains its corresponding means. Based on step 3, we will just have 6 possible samples of size 2. So here it is. 1, 2, 3, 4, 5, 6. 47, 49, 47, 55, 47, 57, 49, 55, 49, 57, and 55, 57. In order to get the mean for our second column, we will just add this and divide it by 2. So 47 plus 49 divided by 2, we have 48. 47 plus 55 divided by 2 equals 51. 47 plus 57 divided by 2 equals 52. 49 plus 55 divided by 2 equals 52. 49 plus 57 divided by 2 is 53. And 55 plus 57 divided by 2 equals 56. So this is the list of all possible samples of size 2 and its corresponding means. Step 5. Construct the sampling distribution of the sample means. We will create a table with 3 columns. The first column will contain the sample mean, the second column will contain the frequency, and the third column will contain the probability. In the first column, we should bear in mind to arrange the elements from least to greatest. So we have 48, 51, 52, 53, and 56. These are from the previous step that we had earlier. We have only 148 in our mean. So what we are going to put in its frequency or in the second column is 1. And in the probability or in the third column is 1 over 6 or 1/6 since we have 6 possible samples. We only have 151 in the sample mean. So the frequency is 1 and the probability is 1/6. We have 252 in our sample mean. So the frequency is 2 and the probability is 2/6. We have 153 in our sample mean. So the frequency is 1 and the probability is 1/6. We have 156 in our sample mean. So the frequency is 1 and the probability is 1/6. When we add all the values in the second column, we will have a total of 6. And when we add all the values in the third column, we will have a total of 1. Alright, we are getting a little bit closer to the last steps. Step 6. Compute the mean of the sampling distribution of sample means. Again, we will create a table with 3 columns. The first column will contain the sample mean. The second column will contain the probability, and the third column will contain the product of the sample mean and the probability. Multiplying 48 and 1/6, the product is 8. 51 times 1/6 equals 8.5. 52 times 2/6 equals 17.33. 53 times 1/6 equals 8.833. 56 times 1/6 equals 9.333. After multiplying the sample means by its corresponding probability, we will add the result. So adding all the values in the second column, we have a total of 1. And adding all the values in the third column, which are 8 plus 8.5 plus 17.33 plus 8.833 plus 9.333, we have a total of 51.99 or 52. So, the mean of the sampling distribution of the means is 52. What I have noticed is my answer in step 6, which is the mean of the sampling distribution of the means, is equal or the same to my answer in step 1, which is the mean of the population. Therefore, we should always bear in mind that the mean of the population is equal to the mean of the sampling distribution of the sample means. That is also stated in our module, so we should always bear in mind that. Because if our mean of the population is not equal to the mean of the sampling distribution of the sample means, meaning our computations are not correct. Step 7. Compute the variance of the sampling distribution of the sample means. In computing the variance of the sampling distribution of the sample means, we are going to follow 4 steps, which are the following. Step 1. Subtract the population mean from each sample mean. Label this as x minus population mean. Step 2. Square the difference. Label this as x minus population mean squared. Step 3. Multiply the results by the corresponding probability. Label this as probability of x times x minus population mean squared. And the last step is to add the results. So here we have a table with 5 columns. The first column contains the sample means. The second column contains the corresponding probability. The third column contains the difference between the population mean and the sample mean. The fourth column contains the answer when we square the difference in the third column or when we multiply the results in the third column by itself. The fifth and the last column contains the product of the corresponding probability and the results in the fourth column or the answer when we square the difference in the third column. In the first and second column, we will just copy what we have earlier in our previous steps. So in the first column, or the sample means are 48, and its corresponding probability is 1/6. 51 and its corresponding probability is 1/6. 52 and its corresponding probability is 2/6 or 1/3. 53 and its corresponding probability is 1/6. And 56 and its corresponding probability is 1/6. In order for us to fill the third column, we will just simply subtract the population mean from each sample mean. So from step 1, we have the population mean of 52. So 48 minus 52, we have -4. 51 minus 52 equals -1. 52 minus 52 equals 0. 53 minus 52 equals 1. 56 minus 52 equals 4. To fill in the fourth column, we will just square the answers here in the third column, or we will just multiply the results by itself. So -4 times -4 equals +16. -1 times -1 equals +1. 0 times 0 equals 0. 1 times 1 equals 1. And 4 times 4 equals 16. To fill the fifth column, we will just multiply the results in the fourth column by the corresponding probability, which is in the second column. So 1/6 times 16 equals 2.667. 1/6 times 1 equals 0.167. 26 times 0 equals 0. 16 times 1 equals 0.167. And 16 times 16 equals 2.667. My answers here are rounded off to 3 decimal places. When we add all the values in the second column, we will have a total of 1. And when we add all the values in the fifth column, we will have a total of 5.67. The formula for computing the variance of the sampling distribution is summation of probability x times sample mean minus population mean squared. The answer here is 5.67. Therefore, the variance of the sampling distribution is 5.67. You can also solve the variance of the sampling distribution using this formula for a faster and easier computation. All we need to do is we will just substitute the values. So this stands for the population variance. The capital letter N stands for the number of elements or the population size, and the small letter n stands for the sample size. So our population variance is 17, and that is in our step 2. Our number of elements is 4, and our sample size is 2. Substituting this, we have 17 divided by 2 times 4 minus 2 divided by 4 minus 1. The answer is 5.67. So the answer here and here is just the same, but this formula is much easier and faster to do. You can also use this formula to check if your computations here is correct. So we are now here in the final step, step 8. Construct the histogram for the sampling distribution of the sample means. In constructing the histogram, this part will cover the probability and this part will cover the sample mean. 8 has a probability of 1/6, 51 has a probability of 1/6, 52 has a probability of 2/6, 53 has a probability of 1/6, and 56 has a probability of 1/6. Therefore, this is how our histogram will look like. So that's all. Thank you for watching.